Hello everyone, I am Mansi. I am from the Department of CSCI from Sri Venkateswara College of Engineering. So today we'll learn about understanding ResNet architecture. So let's move on. So introduction to deep learning. Deep learning is a subset of machine learning that utilizes neural network with multiple layers to model and extract patterns from complex data. It aims to automatically learn a hierarchical representation of data, allowing for more accurate predictions and insights. Deep learning has revolutionized various fields, including computer vision, natural language processing, speech recognition, healthcare, finance, and autonomous driving. And challenges in deep learning, deep neural networks. So vanishing and exploring gradients. Deep learning suffer from the problem of vanishing and exploring gradients during training and hindering the convergence of optimization algorithms like gradient descent, overfitting. Neural networks are prone to overfitting, especially when trained on limited data. And computational resources. Training deep neural networks requires significant computational resources, including high performance GPU or TPU and large scale data sets. So, what are residual neural networks? So, residual neural networks, commonly known as ResNet, are a class of deep neural networks. It was introduced in 2015, and they were designed to address the challenges of training deep neural networks by introducing skip connections, also known as shortcut connections or residual connections. ResNet introduces the concept of residual learning, where instead of trying to learn the desired underlying mapping directly, the network learns residual functions. These residual functions capture the difference between the input and output of the layer, making it easier to train deep neural networks. So, residual networks, also known as ResNet, is a deep learning model. It is commonly used for computer vision applications. It is a convolution neural network architecture designed to support hundreds and thousands of convolution layers. And ResNet provides a innovative solution to vanishing gradient problem known as skip connections. So, building blocks of ResNet. What are building blocks of ResNet? Residual blocks. Residual blocks are the fundamental building blocks of ResNet architecture. They enable residual learning by allowing the network to learn residual functions instead of directly fitting to desired mapping. Each of the residual block contains one or more convolution layer, batch normalization, and ReLU activation functions. So, structure of a residual block. So this is the basic structure of the residual block. The residual block typically contains two parts to identify the path and the residual path. To identify path represents the original input to the block, while the residual path captures the difference between the input and the output of the block. The residual path contains typically one or more convolution layer followed by batch normalization and ReLU activation functions. So the importance of skip connection in residual block is skip connections, also known as shortcut connections. It play a crucial role in ResNet architecture. They enable a gradient to flow directly through the network, mitigation the vanishing gradient problem, and facilitates the training of deep neural networks by bypassing one or more layers. Skip connections allows the network to learn residual functions more effectively, leading to improved performance in various tasks. Residual blocks are key components of residual networks and enabling residual learning and facilitating the training of very deep learning networks. Skip connection play a vital role in residual network by allowing the gradient to flow directly through the network, addressing the challenges of training deep networks and allowing performance in tasks such as image classification and object detection. Overview of popular ResNet variants. So there are many ResNet variants. First is ResNet 18, one of the shallowest variant of ResNet, containing 18 layers, including convolution layer, residual layer, and fully connected layers. It offers good balance between the depth and computational complexity, making it suitable for various tasks. So next is ResNet 50. It is a deeper variant of ResNet featuring 50 layers, including multiple residual layers. blocks with varying depths. It achieves superior complex performance compared to ResNet 18, but requires more computational resources for training and inference. So other variants, ResNet architecture comes in various depths, including ResNet 34, ResNet 101, the ResNet 152, each indicating the number of layers in the network. Deeper variant generally achieves better performance but requires more computational resource. So overview of training the process of for ResNet. First is initialization. ResNet weights are typically initialized using techniques like Xavier or He initialization to ensure proper convergence during training. Forward propagation. During forward propagation, input data passes through the layers of the ResNet architecture and the predictions are made. So loss calculation, the difference between the predicted output and the ground truth labels is calculated using loss functions such as cross entropy loss for classification tasks. Next, backward propagations. A gradient of loss functions with respect to the model parameters are computed using back propagation. Parameter updates. The performance parameters are updated using optimization algorithm like stochastic gradient descent and variance like ADAM and RMS proper to minimize the loss function. So techniques for optimizing the ResNet training. First is gradient descent. Stochastic gradient descent and its variants are commonly used for optimization algorithm for training ResNet models. These algorithm update model parameters in a direction that reduces the loss function. And learning the rate scheduling. Learning rate scheduling techniques such as step decay, potential decay, and cosine annealing are employed to adjust the learning rates during training, leading to more stable convergence and improved performance. So, evaluating the ResNet performance in various tasks and use of ResNet in various tasks, it is used in image classification. ResNet has demonstrated state-to-art performance in image classification tasks, achieving top ranks in benchmark datasets such as ImageNet. Its ability to train very deep networks effectively allows it to capture intricate features and patterns in images, leading to the high accuracy. So, object detection, ResNet serves as a backbone architecture in many object detection frameworks, such as Faster RNN and RetinaNet and YOLO. Its feature extraction capabilities enable accurate localization and classification of objects and images. So application of ResNet in real world scenarios. So ResNet can be used in medical imaging. ResNet is used for various medical imaging tasks, including disease diagnosis, tumor detection, and medical image segmentation. Its ability to extract meaningful features from the medical images contribute to improved diagnostic accuracy and patient outcome. So autonomous vehicles, ResNet plays a very crucial role in enabling perceptron task for autonomous vehicles such as detecting pedestrians, vehicles, road signs from the camera feeds. Its robust performance in object detection helps to enhance the safety and reliability of autonomous driving systems. So thank you for watching the video. Hope you like it.